So today I'm going to teach you part 2 of your electrochemical cells. And today, and if we look at your learning target here on this side, we are going to learn about electrolytic cells, and we're going to explain the reaction occurring within one. Okay, so electrolytic cells are a little different from our voltaic cells in a few different ways, and I'll describe it as we kind of go through. And one of the ways that they're different is that there's kind of two different examples of what you want to accomplish in an electrolytic cell. So this first one, I'm just going to kind of call electrolysis. And if we kind of go through the name electrolysis and what that means, so electro means, electricity, we're putting power into something. And the lysis, the ending of it, is a suffix that means to separate. So essentially what we're doing is we're putting power into something in order to separate the components, okay? All right, so over here, these are our important aspects that we're gonna cover when we discuss this, and then we're gonna switch over and I'm gonna show you another version of electrolytic cells and a different job that they do, okay? So first, I drew the diagram, so if you need to pause your video in order to capture all of this, go ahead, pause this, and then come back to the rest of this lecture. Okay, so first of all, the purpose of here, and I kind of already told you, is to separate something. Okay, so for this example, we have NaCl here, and this NaCl that we have, you notice I have like watermarks here. This is molten NaCl, which means it's kind of like lava. You take rock and you heat it up to a point where it becomes a liquid. We're doing the same thing to NaCl. Now, because NaCl is an ionic compound, it really takes a lot of heat and temperature to break those strong ionic bonds. So it takes a lot of temperature. So we're probably up into the thousands of degrees right now. And we have NaCl that's like a liquid, and it's sloshing around in whatever container that can house that hot of a liquid. Okay. So when that happens, your ionic compound is going to act very similarly to if you dissolved it in water. Okay. So I dissolve, or it's molten, it's a liquid. I have all these ions of Na plus and Cl minus that are floating around as a liquid, okay? Now I have two electrodes in there. And these electrodes, if you notice how this is kind of denoted up here, we have a plus and we have a minus. So this is a power unit, okay? So this is actually plugged into like an outlet, and it's letting all your electrons to flow from your negative to your positive, and it's just kind of making a circuit for us. Okay, so this is actually a power unit. We have to put in energy into this to actually work. Okay, these two electrodes that we have in the molten NaCl, they're not really important, but what you need to know is that they are something made of non-reactive material. Okay, now generally this could be platinum that has a higher melting point. This could be graphite, like carbon rods. So those are two examples of what these electrodes can be. Okay, now the important thing for you to know is that we have these two charges coming out of our power station. So we have a negative and positive. First of all, let's start with the negative side. Okay, where we have the negative side, that means we have electrons that are going to be forming on the outside of this electrode. So you have all these little negative charges that are combined on here. Okay, when that happens, that obviously is going to attract our positive ions, and they're going to come over here. They're going to be attracted to the negative. Okay, so over here we have Na positive, and they're attracting to our electrons. And what's going to happen is they're going to form solid sodium. So what you're going to notice on this, it might be a gray color, depending on what you use, if it's carbon or platinum. And you're going to start noticing that the silvery metal is collecting on it. That's your sodium that's becoming a solid sodium from the ion. Okay? So if we remember our sayings, oil rig, right? So we start with an ion, it's gaining an electron. So that's the rig part. So this is our reduction reaction that's happening. Okay? Now, since all these electrons flowed over here, okay, that means they all had to start over here and flow upwards. Okay, so electrons had to flow in this direction. That means that these chlorines that have the extra electron had to collect over here, okay? So when that happens, our chlorine goes from a negative charge to just regular chlorine. So we're going to have to say that there's two of these here, okay? And you're going to produce 2 electrons, okay? Now, this chlorine is not going to be a solid, it's going to be a gas. Hopefully you remember that, okay? And in fact, when that starts collecting over here, you're going to notice all these like yellow greenish bubbles coming up, okay? That's chlorine gas. Obviously, you don't want to be in the same room as this because chlorine gas is toxic and it can kill you. So it's a good thing to kind of keep in mind with this reaction. All right. So over here, we have our reduction, okay? Now, if you remember from the first video, I had a saying. It was an ox and red cat, okay? This is how you know what your anode and your cathode belong to, okay? Because we have our reduction reaction over here on the right electrode, we know that this one is going to be our cathode. Now, what's different between this and your voltaic cell, this cathode has a, this cathode has a negative charge. That's different, okay? Voltaic cells had a positive cathode. Electrolytic cells have a negative cathode. All right, over here, since this Cl negative is losing electrons, we know this is our oxidation reaction, okay? So this electrode, because it's oxidation, is our anode. And because it's hooked up to the positive power supply, our anode for the electrolytic cell is positive. Positive sign if you want. So this is our positive electrode, our anode. Okay? So in this, the purpose was, as we kind of go back through all of this, and I'll use my cursor so you can see it, we started with molten NaCl, okay, which became ions. We used a power supply in order to separate those ions so that we could get pure substances, okay? So over here on the right, this blue, we end up with just solid Na, okay? So this is a way for industry uses that we can actually get sodium metal, okay? Over here on our anode, our positive electrode, we get chlorine gas, okay? Chlorine gas does also have other uses as well in other reactions, so it's not just a useless product, but it is harmful. So you want to make sure that you're collecting it in the right ways and then you're not in there breathing it in. Okay, so we went through the purpose, we went through our half reactions, we did the charges and naming of the electrodes, and we talked about the products that were formed, okay? Now remember one last little thing, if we're producing 2 electrons over here, you're going to want to balance this half reaction so that it's also 2. So technically you would have your 2 Na plus your 2 electrons, which is going to produce 2 Nas, which are solid, okay? Remember, your 2 half reactions have to be balanced so the overall reaction balances. Okay, that was quick. Hopefully that makes sense. Make sure that you kind of review this. You can watch this multiple times and then ask us any questions you have on that. There's another example that I want to show you real quick. And that is why this could be useful in everyday industrial uses, okay? So again, this is an example, and if you need to pause the video to copy this down, please do so, and then restart the video, okay? This is an example of electroplating, okay? You probably have heard that term before. If not, this is new, which is fine. Electro, again, you're just using electricity or power. And plating means you're taking a metal from one side of your reaction and putting it and coating another metal on the other side, okay? In this example, I'm using gold 3 chloride, okay, in my solution. I have a bar of gold here, And then I have some coin here of less expensive metal, could be nickel, could be silver, it could be other things. So it's just a coin of some sort. It could be even aluminum. What we are trying to do is send gold on this side all the way over to our coin so that it's going to coat the surface with gold and it's going to make it look like a gold coin. Okay. Now, in this reaction, okay, again, we have our power supply, positive and negative. Okay. Just like the negative on the last one, that's where I'm going to start. So our coin, because it's hooked up to the negative side, is going to be coated in all these tiny little negative charges. Okay. Our positive charge here is going to strip away the electrons from our normal gold. Okay. What happens is gold goes from our solid, so our Au solid, it gets its electrons stripped away. So it becomes Au3 plus, and that also produces 3 electrons. Okay. Because gold is losing electrons, this is our oxidation reaction. Now, since we know that's our oxidation reaction, we can go ahead right away and we can label this electrode. Remember, an ox, red cat. Well, this is our oxidation. That's an, so that has to be our anode. And what's the charge of our anode here? Well, we know from our power supply, it's positive. And if we remember, electrolytic cells are kind of the opposite. Our anode here has to be positive. Okay. Since gold is getting its electrons ripped away, we can mark that the electrons are going to flow this direction. And remember, go back and mark that they are actually electrons. Okay. And then they're going to coat the surface of your coin here, whatever it is. So our gold is going to leave the gold bar and turn more into Au3 plus, or gold 3. Okay, that means this gold bar is eventually going to start getting eaten away. You're going to lose mass of this gold bar because you're going to send it from one side and then hopefully go over to your coin. Now what's going to happen over here is that this gold is going to be attracted to these negative ion or negative charges that are on your coin. So your gold is going to go from this 3 plus and gain 3 electrons and form just solid gold. And when this happens, you will notice, hide that. You're going to start to notice that this coin is going to get a yellow finish on it, just like you would expect of gold. Okay, so as that forms this reaction, you're going to get some more gold plating. Now this, because gold is gaining electrons, this is our reduction reaction. Remember, red cat. So this metal is our cathode. And because it's an electrolytic cell, we know that this is a negative electrode. This was our positive electrode. Okay? All right. So we talked about the purpose of this. So an electroplating, it's still an electrolytic cell. It's just a very different type. We're sending metal from one side of the reaction to the other to coat another metal, or it can be a non-metal. You could coat copper, or you can coat carbon if you wanted to, graphite, something like that. We talked about the half reactions. So we have our oxidation and we have our reduction half reactions. We talked about the charges and naming of the electrodes. So anode, positive, that was where our gold bar was. Our cathode is our negative, that's the coin that we're plating. Okay. And we talked about the products that are formed. Here, you're losing mass on your gold bar in order to send it over here, and you're going to finish with a coin that's gold plated. Okay. All right. Just like the other video, if you have any questions, make sure you ask us in class. But that kind of wraps up the lesson for your electrochemical cells.